Okay, so very good.
It started.
Yeah, very good. We'll get started. So first of all, this meeting will be 40 minutes because after that it will expire. So we'll have to have another link. So Kshitij, maybe once this meeting expired, you can share the another link on the group from your
Sure.
Zoom. We'll use that for the next meeting. Now, because it's been some time that our last session was, I think, almost ended by. So what I'll do, I'll kind of start from the beginning, not going too much detail, but we'll still start from the beginning. So, from the beginning, 100 family. Okay. So I'll create a new. Let me create a new status. Background. What happened is not working. IVP 100. So it seems that we will have to do first the release of demand to consensus demand, one or more, one or more. So let's start with that. Now, data form is we will run the copy operator. Kshitij, by chance you have uploaded all master data for supply planning in this.
Yes, I have uploaded it. Master datas.
Then let's see. Copy consensus data plan content to consensus. Run.
I might need to step away for 2 to 3 minutes. My manager is calling me, so I'll just keep the
Yeah,
screen on.
yeah, yeah, that's nice. All right, very good. Yeah, we have so here we don't need the other key figures, so I'll remove. It's really difficult to work remotely. This is not going away. Okay. Nitish, are you back? We also don't need the customer resume. Okay, so this is the first step. So we release the demand from demand planning. It has landed into a key figure. So the final demand plan quantity has landed into the key figure called consensus demand. This key figure is at a product customer level. So these numbers indicates that for this product, this customer will require this much quantity in these weeks. As discussed in earlier sessions, that at each level in the supply chain, at each node in the supply chain, we will have a demand key figure and a receipt key figure. So right now the receipt key figure is nil, which means I don't have any plan to receive anything, to be able to give anything to this customer. And for that purpose, we will run the SNOP time series heuristic. So we'll now go ahead and run SNOP operator. times in the heuristic. So after this run, we will have the total customer receipts available. So this is a customer. So at this customer, what is my demand and receipt plan? What is my demand plan future and what is the receipt plan from future? That is what we will see here. So once heuristic is finished, we'll get to see the number. So we are seeing these numbers. So the total customer receipt is the key figure. That number has been generated by heuristic by looking at the demand of that week. So because I need 222, so I will get 222. Then next comes from where this customer will get this product IBP 100 in 222 quantities or whatever quantity in these buckets. So who supplies this product IBP 100 to this customer? Who supplies this? So DC supply it. So we will have to look at the DC. So we will rename this tab as DC and we will keep appropriate key figures and attributes for you to be able to visualize it properly.
We
And
had template before, no? We
that
created,
was my system, isn't it?
and this was,
This is
and
Shruti's system.
okay, okay. ठीक है.
So that's why we'll have to do everything from scratch. We need here dependent customer demand. Then just um, customer supply. We need customer dependent demand, independent demand, then talk on hand. We have total demand, net demand, output, selected. So we'll have to create a filter. IP100. IP100. Melody. X210 1720. There is one more 3710. I hope these are the three DCs. So plus RDP 100. Okay. So we have reached DC. Now can someone explain this? Or let me first explain so that you understand. So here we see customer dependent demand as 206 at 1720. So by the name of this key figure, this is very clear that this demand is dependent on the customer. So one of the customer or several of the customers might have resulted into this demand. So if we go back to the earlier tab, 206. So 206 is the demand that is coming from this customer, 1710. So these customers had a requirement, had a demand of 206 in each week. And that's why he is getting a receipt of 206 in each week. And this receipt is resulting, so it is all backward traveling that is happening. So because this receipt is there, this receipt says that, okay, you need 206, we will give you 206. And because we will give you 206, so my DC has to have that as a demand. So in each week, you will find that whatever is the total customer receipt there is appearing as the dependent customer demand in each week here. Okay. Why it is same week? Because there is no customer transportation lead time maintained. Because that customer transportation lead time is maintained as 0. That's why that 206 is appearing as 206 in the same bucket. Now, because the numbers are same, you might not be able to visualize it here. But as we had seen earlier, there is 0 lead time maintained. So this is 0. Now, there is another key figure called independent demand. So what is the meaning of independent demand? So in many cases, what happens, we don't want the forecasting to happen at the customer level, which means what? Whatever we sell, whatever of this product, IBP 110. So what we are doing here, as you can see, IBP 100 is being sold to these three customers, right? And obviously these three customers are being supplied by three different DCs. So these are the three different DCs. So in many cases, what we do, we don't capture the history at customer level, or we don't forecast our forecast numbers. We don't forecast our demand at the customer level. So what do? We just forecast at this level. So this is my product. This is my DC. So what did I sell from this DC 1720 to any of the customers? So we aggregate the history at the DC level without considering to which customer I had sold. So we capture the history in such a way, or even if we capture the history at prod log cost level, during forecasting, I am more interested in providing the forecast at DC level itself. I don't care. I don't want to know how much I am going to sell for each customer. So if that is the case, if my demand is forecasted directly at the DC level without knowing how much it is going to be demanded by a customer, in that case, for supply planning purposes, because I don't have any customer knowledge in that case, so this upper key figure will be blank, and all what I forecasted as the demand for this DC will be appearing directly in this key figure called independent demand. I will take a pause. If anybody has understood this, you can let me know. So if I write here 10, why it is? Yeah, you can start. If I'm trying to write, but my cursor is stuck.
So, Pankaj, whatever
If I
project I
write
have done, I
111,
have seen that
if I write,
forecast they do in the hello.
yes, go ahead.
So, whatever project I have worked on, I have seen that forecast they do in the prod log cost. What you are saying right now is that we do the forecast for the independent demand at prod log.
What I'm saying is that it is absolutely possible that a company is not interested in generating the forecast at prod log cost level,
Uh,
or it is absolutely possible that company generates forecast at prod log cost level as well as prod log level. It is absolutely possible to generate the forecast at the product family and customer region level.
uh,
So there are several possibilities at which the final demand plan is getting generated.
so,
Even in our case,
can other way can be also done, like they will generate it prod log cost and they will aggregate it to prod log.
yes, that's also possible.
ठीक है.
So what I am trying to explain is that irrespective of at what level the demand planning has been done, and it is highly possible that they create the demand numbers at various levels. So when I talk about the SNOP process, we did see that the last tab, which was 40, when the SNOP process was going on, the attributes were product family and customer region. So the demand planning happens at various different levels. However, when we do supply planning, the obvious two possible points where that demand plan has to come in supply planning are either we bring the number in the consensus demand key figure here. If this is the case, and this will be more understand if you understand more if that diagram is in front of you. If in front of your eyes, if you look at that diagram, then this will become more easier to understand. 17, 20, 17, 20. It is all about this diagram. So then we have this customer. So who is this customer? Let's say. What happened? Okay, this is the customer. So what we are saying here, what is the meaning of this, having 100 in week 1 here for this customer? 100. So what it means in week 1. So let's say next week, this customer needs 1000. So who will give 1000 to this customer? 1720 will give the 1000 quantity to this customer. So instead of telling that 1000 quantity is needed by this customer, and then heuristic in turns makes that 1000 as a demand to this 1720 in a key figure called dependent customer demand. Sometimes we don't want to start my supply planning from customer level. I just want to know what is my demand, because this guy 1720 is the only person who is going to supply. So this 1000 quantity can be seen as the demand directly at 1720 as well. So I don't want to plan at the customer level. Imagine that this was being, so this 1720 was given to two customers, and the other customer also needs 500 quantity, 5000. Okay. So then what will happen after heuristic run? And both of them has customer source that points to the same DC. So what will happen? This 500 will become dependent customer demand for this DC coming from this customer, and 1000 will become dependent customer demand coming from this customer. So ultimately what we will see in week 1, demand dependent customer demand as 6000. So in many cases, customers, they don't want to do supply planning starting from customer. So what do they do? In the demand planning process itself, they see, okay, related to the 1720, I have two customers. So they do aggregation of their demand number at this DC level. By doing the aggregation, they find that 1000, 5000 becomes 6000. So they understand, okay, for IBP 100, my demand at this DC is 6000. So instead of releasing the forecast of the final demand to consensus demand, they will directly release that number to independent demand key figures. So we will create a copy operator where my final demand numbers from demand planning will be directed to populate the independent demand, and independent demand key figure represents the demand which is at this DC for this product. It does not, it has no connection with any customer. It indicates this is the quantity I need, this is the demand I need to cater to all the customers who will come to this location 1720. So it's that number. Okay. Now anybody else has understood what is the meaning of this number? So at a DC, I will have either demand coming from a customer like this, or if I have not released my demand, if I have not created my supply chain network to include the customers as well, if my supply chain ends at my DC itself, then I will release all my demand numbers in the independent demand key figure, because these will not exist in my supply chain. The customer product will not be there in my master data. Customer source will not be there in my master data, because I don't want to plan at customer level. I don't want to know what is my weekly customer specific demand. That's a decision that the implementing company takes. It's a business decision. So if they decide I just want to plan at my DC and beyond, then their demand planning numbers will land in this key figure, which is independent demand key figure. Beyond this, everything remains the same. So if the number lands in this key figure called consensus demand, then also this will get reflected at DC as a demand in this key figure, dependent customer demand. And if that customer is not modeled, this entire sheet is gone, then the numbers from demand planning will land in this key figure, creating the demand for this DC. So instead of 206, your demand will come from independent demand key figure at the DC. Okay, even if you don't understand fully right now, it's okay, but we'll just continue. So beyond this, if you recall what we learned last time, we had taken only one number, that was for you to be able to really control that number and understand how it is moving in the timeline. Now all the week numbers are there. This is the reality how it happens in the projects. So you get to see the weekly numbers in all the buckets because that is what we forecasted. So here, since we didn't have any independent demand, if there was any independent demand, then that and customer dependent demand, these both these will be added, and that becomes the total demand for that week. Okay, because we don't have, so it is we don't have independent demand, so that's why 206 stock is 0. So your net demand becomes 206 minus 0. So 206 is your net demand. And then because I have a net demand of 206 in week 28, so I need to get transport receipt is about getting this product at this DC in this week. So I have a demand of 206, that is the net demand, and I will get 206 in this DC.
रिकॉर्डिंग भी शुरू हो गया.
Okay. Go option exit. Okay. So we were here in DC. We have this demand number 206. We did not have any stock on hand, so net demand becomes 206, and then we have the transport receipt of 206 because we needed 206, and then the projected stock is blank. Why? Because in this week we needed 206. We are getting 206. There is no extra, so that's why our projected demand. What it means is, after fulfilling the demand of that week, my receipt is left with anything more because there is nothing left. So this projected stock is 0. So in next week, what happens? This projected stock, if there is anything, will deduct from the net demand. So if imagine I had a transport receipt, just imagine I had a transport receipt of 300 here, 3000. Okay. So what happens? I have got how much extra? So heuristic itself will understand. So then I have 2794 extra. So then it will not create any transport receipt for the next subsequent weeks till this projected stock of 2700 is not exhausted. So all these demands will be fulfilled by this projected stock because I already have got received 3000 here. So why to bring another 206 next week? So that's how this projected stock works. It indicates you how much you are left with at the end of that week after fulfilling the demand of that week. And if there is something left, then that will be used to fulfill the demand of subsequent weeks till the time it can complete. Okay, it can fulfill. So that's how this planning happens. And the same thing happens at each of the locations. So the demand numbers are different here. So different receipt numbers are there. But otherwise, the concept remains the same. The same key figures will be appearing here. Okay. So we understood customer, we understood DC. Now this DC is getting this number 206 as the receipt. So it must be resulting into demand at somewhere. So that somewhere is nothing but your production plant. So in the next tab, we will look at the situation at plant. So this is plant dash FG. So I should have copied. So I will make this as plant at FG. So for now, let me quickly edit the key figures. So here, our key figures will be dependent. This, can you cross this key figures which I say, because it is not taking control from here. So remove this dependent customer demand. Yeah, and independent demand also. And transport receipt. And add dependent location demand. In the search, right? Dependent location demand. Yeah, it will come. Okay, the first one. Yeah, take it to up, select that. Yeah, yes. All the way to the top. And next one is production receipt. Production receipt. Yeah, take it above projected stock. Just, yes, here. Correct. And that's all. I will now control. In the filter, we need another filter. So I have to create another one. So what are the planned location for us? 10, 10. I think 3710 is a plant. And then 1710 is a plant. Okay. Now 3710 is a DC. We have one more plant, which I don't recall what is that plant. Yeah. Do anyone recall what is the other plant we have? 10, 10, 17, 10.
1310 and 6210.
Plant.
Plant.
10, 10, 17, 10. Two plants are there. There is one more plant, which I am not able to recall. Sorry. Ten, 10, 13, 10, and 17, 10. 13, 10 is the one. So here. Oops. Yeah. Okay. By the time I do an update on the filter, can anyone explain why you are seeing minus 222 here? Can someone try? What is the meaning of this minus 222? Why do we have minus 222 there?
Because we
Okay,
don't have stock on
On
hand
hand is
in
zero.
the and stock on hand minus dependent demand will give you negative projected stock.
we don't have stock, correct?
Yeah, we don't have stock. So when
And
we don't have
receipt is
stock,
also blank.
we have a lack of minus 222
Why
quantity
do we have lack? Why do
because
why don't we have lack?
demand is 222 and currently we don't have anything uh, to provide to the customer.
Why
So
don't we
minus
have negative numbers in the other bucket? We
other
don't have
bucket.
anything today, then we don't have anything for next week also. So why don't we have projected stock negative in next week? So answer is
Negative.
correct. We don't have anything this week, but you're only looking at stock on hand. That's not the only receipt that works to fulfill the demand. Why are we running heuristic? We are running heuristic to generate receipts which will fulfill this demand.
Projected stock is stock on hand plus receipt minus demand. So demand value is 222. So it will be like 0 plus 0 minus 222. So that's why
Which
negative.
are the zeros?
The stock on hand and production receipt.
Okay, good. So in this week, we don't have any production receipt, we don't have any stock, but we do have demand. So Dipti, what you said was correct, but I think you could not you could not explain that even the receipt was zero. So the
Yes, yes.
projected stock is minus 222. Now in other buckets, we have the production receipts. This was the main reason why heuristic was run. That looking at the demand numbers, give me a production plan so that I will be able to fulfill my receipts, fulfill my demand. So it does that. But then in the first week, it is not doing. Why it is not giving a production receipt in the first week when there is a demand of 222 quantity? Why it is giving production receipts from the next week? So this is happening because there is a production lead time. So what happens? This number 222 is needed in the week 27, which is the week in which we are. So we cannot produce 222 starting this week and finishing this week because our master data. So our which master data should we look at for the production lead time? Anybody can recall?
Header production वो वाला
Source
header.
header. Production source header. Okay. So we look at the production source header and we'll understand why it is taking 1 week. So the reason for not having any production receipt in first week is because we have a production lead time of 1 week. So that's why it is not able to give production receipt there, and that's where our projected stock is becoming negative. Okay, so IBP 100. So if you look at this one here also, it is alternate of this one. So at 10:10, if I go to the right, production lead time is 1. If I make it 2, save it. What will happen? So I have made it 2 now, and I have saved it. 10:10 itself, I have done it here itself. Record changed 1. So what do you expect now? Can anybody guess? While I'm running the heuristic. What will happen now? I have made the production lead time as 2 weeks.
So the projected stock will go higher. Means minus 222 minus 222. So 444 till second week. You know.
Why it will become 444 in first week? No,
Because
in first week, how much will be the projected stock? In second week, how much will be the projected stock? That will,
first week it will be minus 222. In second week it will be minus 444.
yes. Palak, do you agree? Do you disagree? Before I do refresh, you have the chance to agree or disagree.
Mm.
Or you can say no answer. Or you can say, why are you asking me?
Because production receipt will not be generated, na? It will be generated after 2 weeks. So the
Yes. What is
projected
that week? Week 29. So the
week
first
29.
production receipt will be in week 29. So that's why in these 2 weeks, we will not be having any production receipt, and obviously there is no stock on hand. So we will have the projected stock of 222 minus in first week and another 222 in second week, but previous will make it 444 in the second week. So let's see. What I am saying is true or heuristic things other than what I am saying. So let's find out. Okay. So what it is not doing is it is not adding up. So it is just calculating the, which is a little strange. It should have done the projected stock to be 444. So I will have to check. It is in the SNOP heuristic setting. I think this is the right time to touch upon that also. So the operator that we are running, so the operator that we are running, so let's now take a look at that operator. So we have an app called SNOP operator. Okay, SNOP. So this is the app. This is the app SNOP operator profile. Rather, it is not an app. It just takes us to the profile itself, inside the profile, inside the app. So here we have several operators getting created. Now for our planning area, Kshitij, what is the name of your planning area?
TKUPA.
TK. J is there? No.
No, this one.
TK. Okay. Oh, there is one more Jha. Vijay Jha is also there.
Yes.
In your system environment, there is one more Jha. Okay. So in Kshitij, in your planning area, we have these many SNOP operators. So you will see from the name. So heuristic is SNOP operator. Supply optimizer is another one. Forecast consumption. All these are SNOP operators. Now, the one that we are running to generate our supply plan is this TS-based supply heuristic. So if I go inside this, which we should as a consultant, then it has settings. It has details inside it, which controls the behavior what we are seeing right now there. So you will see here it is infinite without shortage. There is one more heuristic which is called finite heuristic. So the radio button, if I click here, then this heuristic will work as finite, which means it will not produce more than the capacity which we have not reached as yet. But once we reach, then we'll understand. So we have the control of this heuristic behavior using these tick boxes and radio boxes. So there are several things which we normally should know. These are the ones which normally are asked in the interview: receipt balancing policy, merger policy for key figure, and minimum transport handling policy. Now, I'm not going to touch right now, but it is recommended that when you do preparation for interview, at least these key figures, the meaning of this and the drop down options that are available is understood, and it is given in the help. However, what I came here to show you was this: carry over negative projected stock. So this heuristic which we are running right now, this is not ticked. If this was ticked, then it would have made that 222 in the next step, in the next bucket as 444 minus 444. Because this tick is not, because this box is not ticked, that's why my heuristic is not doing the projected stock as 444. Is this clear? If I tick that and then run heuristic, it will make it 44. Is it understood? So there are few more controlling characteristic within the SNOP profile which can influence the result that we are seeing. And depending upon the customer requirements, these ticks are made. Now, in what business scenario this tick will be required? So I'll tell you that. See, what is the meaning of this 222 not being fulfilled in the first week? So this means that this production plant need to send 222 quantity in first week to the corresponding DC. That is the meaning of this 222. This is the dependent location demand. Now, when this 222 will be sent in current week, it will take 1 week to reach there. So even at DC, I have to see what is the transportation lead time between the plant and the DC. So if imagine it is 1 week, then it will take 1 week to reach the DC, and then it will take there is no lead time between DC and customer. So what it means, the customer is going to ask for this 222 quantity in the second week, because it is 1 week from here to there, here from plant to DC. Now, if we are not able to produce anything in this week, then obviously I can only produce by next week. So if I produce by next week, then the customer can only receive after 2 weeks from now. Demand, customer can only get after 3 weeks. So is customer willing to wait is the question. So in those cases, if this company is Apple, so it will carry over this demand to future buckets, because customers are willing to wait. So whenever they want for iPhone, if it is not available, they will wait 1 more week. So then it makes sense to carry over this demand to next week and ask heuristic to produce. So this, you see what heuristic is doing here. Even though it had shortage in last 2 weeks, in the third week, it is only producing 222. Why? Because it understands the previous demands. Now customer is in no mood to get it late. So late fulfillment of demand is not accepted by customer. In those scenarios, this will not be ticked. This will not be ticked. But if customer is willing to wait for the late receipt, then we will tick this. And I'll show you, if I tick this, what it makes to our. Kshitij, can you make it edit and tick this? Some
Sure.
of the things. does not want to take command from me in some of the fields. So you have to first click on edit on the top
Edit on the top.
corner right, top corner right, all the way top.
Yeah, all the way.
Edit button, blue color button is there.
Just a second. Oh, this one. Okay.
Now you come down and then you can take carry over negative projected stock. Take this, save.
Save.
Now you go to Excel just for making sure that it is done. So you just log out and log in. One log out means disconnect and connect. Yes, disconnect and log on. Yeah, and then you can run the SNOP operator. So in supply planning, so the way we are seeing here, it will be more important for you to run this and understand the impact of various attribute values, which I will share, uh, which one you need to run, and then some of the meaning of these settings. It's all business here. Demand planning was very technical. Here it is very much business driven. Okay, now you go to the run and run the SNOP operator. Yes. Okay. In the drop down, yeah, select heuristics and run. Next. Run. Okay. In next 20 minutes, I think if we have more time, I will take more time. So maybe half an hour. Just
Now it's changed. Minus 444.
uh, so it is changed to minus 444. And then look at the production receipt of third week, 666. So why it is 66, 666 now? Production receipt is 666. So
Because
now,
we have demand from the
yes,
start
go
of
ahead.
the week. Yeah, because we have the demand from the 27th week, 27, week 28, and then week 29. So all together is 666. So net demand is 666, and the production receipt is 666.
Correct. So you're right. So what now heuristic is doing, it is not leaving the demand of the previous weeks because it was unable to produce. So what it is doing, whenever I am able to produce, I will produce the demand of third week as well as the other previous 2 weeks for which I was not able to produce, but still I will produce it in the third week so that I know my customer is going to wait and then I will be able to fulfill. So depending upon the business scenario, this stick will be used. Okay, so now we'll move on, and then let me in this next tab, I will do plant capacity. So actually, plant so this is very important now, and this one is plant FG. Can you write this DC2, rename this DC2 to plant FG, plant dash FG, double click or right click rename. Yeah, plant dash FG. So meaning what? At plant, we are looking at the plan of an FG. And looking at the plan of an FG meaning what? What are the demand numbers here and what are the receipt numbers? And then what is the projected stock? That is the meaning of this. Now, what is the meaning of plant dash capacity? So we have learned earlier when we are learning the master data that whenever the production happens, so in this week, what is happening? We are producing 666 quantity. So producing something requires some machines to be used. So there are machines on which the production of this 666 quantity will take place, correct? So now we want to know how much capacity my machine had in this week. And because of the fact that we are producing 666 quantity in that week, how much capacity is being utilized. So that is the view I want to have in this plant capacity. So in that, and there is a capacity view as here as well. Let me see what is that. Yeah, I think we can use this. Okay, so first of all, let me make a filter which only shows me the resources at 1010. So we'll focus on 1010 only for now. Same thing is going to happen for other location as well. Resource ID. Resource ID and it will be 1010 assembly 1010 pack. These two. Oops, pack is gone. 1010 pack. Okay, and we'll also keep the location ID as 1010 plus. So this is IBP 100 resource. Okay, so now let's see. So now if you might not recall, so in case of resources, what it indicates is that at the plant 1010, okay, I think we will have to use the other assembly, not the capital letter, rather the small letter. So filter. Okay, it has come. So 1010 assembly and 1010 pen. Tinting pack. Small, no, this is capital assembly, not this. What is this? 1, 2. This one and pack 01. This one. I think these are the two. That's it. Yes. We'll remove this for now and we'll give the product. Okay, so product ID is IBP-100. Let's do this. Okay, this is the right one which we are using. Okay, now this is a resource called 1010 assembly and this is another resource called 1010 pack. So these are the two machines which are there in this plant 1010. Now these machines are available 24 hours in a day. So in a week, they are available for 168 hours. Okay. So I will write down 168. Why this key figure is blank? Because there is a key figure file that we did not upload. So there is a prod resource file is there. So there is a file which we can upload, but before uploading that file, we can either upload and or else we can put it manually also here as you can see. So first key figure, which is capacity supply, indicates that for how many hours this resource is available. Can it be available less than 168 hours in a week? Can anyone you think of a situation when it will be not available for the 168 hours and it will be available for less number of hours in a week? Do you think it is possible? How 168 has come? Because we have 24 hours in a day, so 7 days in a week, so 24 into 7 is 168. That is how 168 has come. But can it be less than 168 hours in any situation? Can you think of?
In case of holidays, like
If the plant is closed.
yes, plant is
So
closed.
if the itself is closed on 2nd October or 15th August, then obviously that one day's 24 hours will be less, and then this entire week's capacity, available capacity will reduce by 24 hours. That's good, very good. The another thing can be that within a day, you need some time for maintenance. So labor work in shifts. So after every shift of 8 hours, it might be possible that the machine needs half an hour of cleaning, etc. cool down for it to be able to start the next shift work. So there can be a maintenance or breakdown period within a day as well, depending on how is the machine. Okay, so there are scenarios when its availability can be less or it can be more also, because imagine a machine which has two arms. So imagine a machine being a robot. So robot will have two arms. So from two arms, if it is doing packaging, then at the same time it can do packaging for two products. So then effectively in one day itself, it is having 48 hours of capacity. Understood? So if I have defined the resource as in such a way that it has got two arms, so then within 24 hours it is doing the work of two individual machines. So then it will have 48 hours, and then accordingly the weekly capacity will be double of 160. But without going to those details for now, you can clearly understand that available capacity has nothing to do what I'm going to produce or not. Available capacity is all about the availability of this machine to be used. That's it. It has nothing to do with what I'm producing, what I'm how much I need to produce and all that. Everything is independent from the capacity supply. Capacity supply, it's a fact that this machine at this plant is available for how many hours in a week. That's it. It has nothing to do with what we are producing, when we are producing, how much we are producing, who is available, who is not available, labor, etc. Nothing. It has nothing to do with all those. Okay, so that is this key figure. I'll just make a save here. Where is the save? Save data. Then comes the next key figure, which is called capacity usage of production. So let it get saved first. Okay, Kshitiz, let's upload that file. Can you go to data integration job and then let's upload the file?
Sure.
It is not allowing me to do it manually. Data integration.
Oh, sorry.
No, below, click on the plus below, down, plus. Then select the key figure instead of master data. Key figure. Planning area is our planning area. TK. Yes. Then browse. Yes. Browse. The RDS file. Yeah. Key figure data. We will have weak resource lock. Second last. Yeah, this one. Okay. Open this. So separator will be colon. So the next. No.
Oh, okay.
It will be colon. Operation type will be insert. Update. Separator is colon, not comma. Colon.
Colon.
Semicolon, sorry.
Semicolon.
Semicolon.
Okay.
Insert update. Okay. Now save. I assume that this key figure in errors log only. So there is a refresh above that. You can just click on refresh.
Yeah, it's refreshed.
Go to the Excel now and do a refresh there. Yeah, okay. Very nice. So we have got the capacity supply loaded now. So happened here is that our filter is gone. So I'm now controlling. Well, let me control it. This will work. Okay. So now what it indicates, if we look at the first two, first resource is at 1010. It says I have 3000 hours of available capacity for a week. Okay. So without challenging right now, why it is 1 to 3000 instead of 1. So this is what it is given. So this resource has 3000 hours of capacity in a week. Okay. So that's why it has 3000 in each of the weeks. Then look at the second key figure. It says capacity usage of production resource. So this is 666 in this week, and then we have 222 in other weeks. Does it remind you something of this number? Have you seen this number anywhere? This 666, 222. Do you recall such number somewhere? So if we go to plant FG, we will
Production
observe that.
receipt.
Yes. So we will observe that IBP 100 had got a production receipt of 666 quantity in this week. So this is quantity. Keep in mind. So 666 is the each piece. In this case, unit of measure each. So now this 666 quantity is being produced in week 29. When we produce this product, IBP 100, we know that there are two machines, 1010 assembly and 1010 pack. Those two machines will be used to produce this product, IBP 100. So this quantity is going to utilize the capacity of those two machines. And how much capacity it will utilize? So one quantity of this product requires 1 hour, one unit of time that we have. So all this setting is maintained in the master data that we have seen earlier, and you will have to see this again and again, obviously, to be able to fully understand this concept. So here, where have we maintained this master data, that how much time one quantity of this product needs on the machine, that is maintained in production source resource. There is that master data, production source resource. This is where this detail is maintained, that any FG, one quantity of that FG, one being produced on a resource, how much time it takes. So here is that maintenance. So IBP 100 at 1010 assembly requires 1 hour. 1 means 1 hour. So it requires 1 hour. And how does it understand that one quantity of FG requires 1 hour? Because in the production source, oh, by mistake, I removed the production source header. Because in the production source header, the output quantity is maintained as 1. If you maintain output quantity in production source header as 2, then it means that to produce 2 quantity of that FG, I need 1 hour. Because it is 1 there, so that's why it indicates that one quantity of FG requires 1 hour of this machine. Similarly, 1010 pack. one quantity of the FG requires 1 hour of pack. Let me make it 2 so that I will be able to show you. I'm making this change. So this is how my production quantity results in providing the capacity requirement, how much capacity, how much hours I require on that machine. Okay, so very important to again visualize here. Everywhere you have two things. One is how much I need, another is how much I have. Everywhere you will get to see what is my demand, what is my receipt, what is my demand, what is my receipt, or what is my supply. Okay, this entire planning runs on that single concept of visualizing my demand and supply. Okay, so in this case, capacity supply is how much I have, how much hours I have in a given week. And then this capacity usage of production resource is how much hours I need on this resource. And this need is coming from where? It is coming from the production quantity. Production quantity of FG results in the need of hour on this resource, on each of these two resources. Okay, so I will once again I'll run this heuristic, and you will have to explain the change that I have made is resulting into where? Resulting into change in the number where? So what did I change? I changed that the product IBP 100 requires 1 hour in 1010 assembly, but it requires 2 hour in 1010 pack is the change that I have done in the master data. And now I'm running the heuristic. So where do you expect to see the change in the key figures? Which key figure should have changed? Change in the number?
Capacity utilization.
Capacity utilization is the percentage. This is the place where we
Usage.
uses how much hour I need on this resource is here. So these are the numbers that are based on the earlier setting. Now that I need 2 hours, all these numbers will double. If I do a refresh, these numbers will double. Means I need these many hours. 666 per double. 1332 hours on this pack machine. 444 hours. However, in this machine, I need 666 hours and 222 hours. Can someone else explain what is this happening? Why it is happening? Kshitij, can you try explain why this is 66, 666 and this is 1332?
So
No.
for 1010, for 1332, it is also calculating the same number for the 666 for as a combined number for the 1010 pack as well. Like 666 for 1010 pack as well, and 666 for assembly as well.
So, okay, just explain why do we see 666 in the 1010 assembly? From where this number is coming? What drives this number?
Plant FG production receipt.
Plant FG production receipt. So what does this mean? Here 66 means what? We'll see. So this is this number. In week 29, I see 666. What does this mean? This means I am producing 666 quantity piece each of IVP 100 in week 29. So this is quantity. This is each. While I go to this view, we are seeing 666 here. What is the unit here? Is this quantity or something else? We are talking about capacity here. So when we said 3000, I said I have 3000 hours in a week. What is this 666? What is the unit of measure here?
The
We're
total
talking about
usage out of 3000.
Yes. So 666. What is the unit of measure of this 666? Each piece hour.
Each.
RO.
So
Oh, R. Yes.
how much capacity will be in each? While the capacity available is in hours, how much capacity I want to utilize on this resource need to be in hours. So what it is saying here, because I am producing 666 quantity of that FG, hence I need 666 hours on this resource. This is what is the meaning of this 666. And how does it understand that 666 quantity of FG requires 666 hours? How does it understand that part? That it understands from the master data that we saw. In the master data, we have said one quantity of IBP 100 requires 1 hour of capacity of this 1010 assembly machine. That is why it is taking 666 hours. In the other one, I have said one quantity of IBP 100 is going to require 2 hours of 1010 pack. Because I have done that maintenance in the master data here, that's why 666 quantity of FG production receipt is resulting into requirement of 1332 hours in 1010 pack.
What is the name of the attribute? Capacity
Capacity consumption rate.
consumption
Yes,
rate.
I have maintained 2 here. So what is the meaning of this?
Capacity consumption
One
rate.
quantity of FG IBP 100 will result into will require 2 hours of this 1010 pack. So because I am producing 666 quantity of IP to 100, that's why I need 666 into 2 hours on this 1010 pack. If I make this as 3 now, what it means now, one quantity of FG100 requires 3 hours of 1010 assembly. If I do this, this is the very favorite question in interview. How do we calculate the capacity requirement on a resource? So the capacity requirement on a resource is calculated by multiplying the FG production receipt quantity and the capacity consumption rate maintained in this master data. They will also ask for the master data in which this rate is maintained. Okay, so these questions are very favorite to the interviewers because somebody who understands this looks to be understanding everything. So this is a little complicated. So okay, so I did that. Now I'm going to run. So what will change with this? What I changed, because I changed the master data. What change we will be able to see after the run? What will happen? The capacity usage key figure will now get tripled for the first resource. So 666 number will be around 1880 or 1896. This number will change. It will become 3 times now because I said one quantity of FG production requires 3 hours on this machine. And now heuristic will give accordingly the capacity usage. Oh, 1998. So whatever is, and the rest of the weeks are 222 into 3. Okay, so I think we have kind of seen the relationship between the production receipt of FG. So this number being 666 and 222, so the production receipt quantity multiplied by the capacity consumption rate maintained for the each resource. So this product IBP 100 is going to take 3 hours on this machine 1010 assembly. So this is multiplied with the production receipt quantity to give us how much capacity I need, capacity usage on that machine. Okay. And then the next key figure is just a simple percentage calculation, and that's dynamic also. So we have a key figure called capacity utilization, this one. Capacity utilization. So this is 66, 67%. How does it come? It is a simple formula, 1998 upon 3000. Okay. So it says that my machine is only 67% of capacity is being utilized in this week. That is the meaning of capacity utilization. So the fact that I'm only producing 666 quantity of an FG in that week, that results into a capacity utilization of only 66, 67%. In subsequent weeks, it is only 22%. Similarly, for the other machine, it is 44% and 15% and all that. So these are the three important key figures. Capacity supply talks about the availability of number of hours that a machine has in a given week. This key figure has nothing to do how much production I'm going to do and all that. No, it is only about the availability of capacity in terms of hours in that given week. The next key figure is the most important key figure, which is dependent on the production that is happening. So because we have a production receipt of 666, accordingly, a capacity usage or capacity requirement is determined, which is a variable based on the quantity of FG being produced. And then the key utilization is simple ratio between capacity usage of the production receipt upon the capacity supply. So that is 67%. Are you okay till this point? Okay. Now, beyond this key figure is just an information that on this machine, one product is being produced. So it is possible that there are several products that is being produced. In those cases, what will happen? This utilization will be result of the production receipt of different other FGs as well. And then it is important for us to know how many products are produced so that we know that this capacity utilization is not coming only from one product, rather other products are also resulting into the capacity utilization. So in IBP 110 and IBP 120, if we put some demand in those products as well, and then run heuristic, because those products are also being produced on this these resources only. So then you will be able to see 2 and 3 numbers here, because then your capacity will be utilized from the other FGs as well. And capacity demand. So this is the same capacity demand of the production resource or capacity usage of the production resource. It's the same 1998, 1990. Okay. Now I think this is enough for today. I also recall that last time I had talked about the dependent demand of the components, and then how transport receipts are generated there. So all in all, I guess this was the part which was left. So obviously, we can kind of say that the supply planning concepts are covered, but in order to really understand the supply planning to the extent where we are ready for interview, let me once minute. Yeah. So we will have to do more practice, which includes, now I'm going to show you. So this is a different Excel. In this, we have got supply planning related topics very organized in a very organized way. So first tab is about the process, supply planning process. So these
Are you
process
sharing
steps of
something,
supply
Pankaj?
planning. So first process step is, what happened? Sharing is gone.
Uh,
Oh no, okay,
no,
okay.
I
It is was sharing earlier. No, I will share. Okay, 1 minute.
So I'll stop sharing my
I will
screen.
share. You will stop sharing. You stop sharing.
Okay.
So we have 10 minutes. So we'll finish in 10 minutes. Okay. Make myself as first. Okay. Okay. So now this Excel is visible. So I will share this Excel, but now you need to practice more. So this Excel has first tab as process. So this is the supply planning process. So this process has 6 steps. The first step is release demand plan to supply that we have seen. Okay. Then second is review, create correct supply planning input parameters, which means the master data types. So we have seen which are the master data types relevant for supply planning. So we have learned about location, product, customer source, location source, production source, error, etc. So we do review to them. Then all of these master data types, many of these has certain attributes that has an impact on the supply planning result. So for example, the lead time, okay, there is a sourcing ratio. So there are several such attributes. Lot size is the other one, which has an impact on the output of supply planning, which is your total customer receipt, transport receipt, and production receipt. These are the outputs of supply planning. So when we run the supply planning, these key figures get populated, and also the capacity utilization percentage. That is also an output of supply planning. So there are attributes within these master data types which has an impact on the output key figure of supply planning. And then there are some input key figures for supply planning. So those input key figures, one of them is consensus demand, other can be independent demand. So these things are there. So then what we do as a second step, we review which are the master data types. In those master data types, which are the attributes that are required for our supply planning run, which are the input key figures that must have number before we run supply planning, etc. And these all comes from CIDS, obviously from the backend. Then third step is run supply planning. So that we have seen how to run the supply planning SNOP profile. And then fourth is the review receipt element. So these are the receipt elements. So total customer receipt, transport receipt, the spelling of receipt is incorrect. So we'll correct that. Production receipt, unknown external receipt, and capacity utilization. So these are the output key figures of the supply planning. So this is the fourth step. And then as fifth and sixth step, what we do, we send back these receipt elements to the backend ERP. If it is ECC or any other backend system, then these output of heuristic goes back to ERP, and then these orders are created. So transport receipt becomes stock transfer order, production receipt becomes production order, transport receipt again to vendor becomes purchase order. So then these are the receipt elements. These are the orders that get created into backend ERP. And so from IBP to CIDS to ERP, it goes as a fifth step. And then receive stock and incoming receipt back into IBP. And then these are all incoming receipts. So this is little difficult for you to understand for now. So this step number 6 you can leave, but and also we have not touched upon the step number 5. But at least these first 4 steps you should be clear upon. Okay. So this is the supply planning process. Now in tab by tab, we have got all the details here. So what are the master data types that are required for supply planning? How does it look, etc. So you have done some hands-on also on this one. So then this is in this sheet 2, we have a view where these key figures that we just saw in different tabs, I have noted in one view. So customer demand is the demand at customer, total customer receipt is the receipt at customer. This results into dependent customer demand at DC, and then stock on hand at DC. Inventory correction we did not talk, and minimum transport receipt we did not talk, but we talked other key figures like net demand, projected stock, etc. So this is the view where you will see that the transportation lead time, if maintained, has an impact on the key figure numbers, etc. So this is the one consolidated view of the entire network. Then in supply revision, I think the same thing is talked here as well. So now attribute values. So we have noted here what are the important attribute values within a master data type. So, for example, if there is a location product, in the location product, along with the location and product, a subnetwork ID is the important attribute from supply planning perspective. There is nothing more that I have noted here. For location resource, there is a capacity supply attribute and then capacity supply time series indicator. So these are the important attributes. And after this call or whenever you get time, you should go to the SAP help and then look at the meaning of these attributes there, what it means, what is the impact, and then reading that you can run SNOP and then look at the impact. What is the meaning of looking at the impact? The way I change the value of capacity consumption rate from 1 to 3, 1 to 2, and then run the SNOP operator and then look at the key figure to see the impact. That's how we should be able to see the impact. Customer transportation lead time. So you go to the customer source, change the transportation lead time and see where the number has changed, which key figure has got now the different numbers, etc. So I have noted here all the different acts within a master type that are usually used in different projects. So lead times, lot size, minimum lot size is there, location transport ratio is there. So these things we did not get time to cover in detail. Then once you make changes in these attribute values, it will result into difference in the numbers that you see in production receipt, transport receipt, those output key figures, you will see different number. So it's now you can read this in SAP help and then you can try and see what is the impact on the key figure values. So this is where we have got different attributes which are important and relevant. In the hands-on exercise also, here is a hands-on exercise. In fact, I have said that we should work on the lead time, minimum lot size and rounding, capacity, etc. Maintain below. So this can be used to perform some hands-on exercise as well from there. Now input key figure data. So consensus demand quantity, consensus demand, we know it is coming from the demand planning. Stock on hand is one of the input key figure. Then inventory correction we did not talk. Safety stock, minimum adjusted, all these we did not talk because these are a little bit advanced. We have noted the meaning of these key figures, but for now it will be difficult for you to understand the meaning even if you read it. So stock on hand you understand, but then inventory correction, etc. And then we have capacity supply. We have seen the meaning. How many hours of resource available within a week? Okay. Is there a hands-on exercise here? Yeah, there is some hands-on exercise here as well. So you can perform these hands-on exercise yourself. And then we have SNOP operator. So this you have seen how to run it. Then we have optimizer, etc. So you can leave that. So in the MDT attribute value, we have hands-on exercise. And in the input key figure data, we have some hands-on exercise. So you can try to do these hands-on exercise yourself. And then I will maybe in 1 week's time, if you are able to tell that you have been able to do this, then we will have one more session to see the readiness. And then after that, we will set up a meeting with Pawan to see the end-to-end planning. So starting from the history to forecast to release to supply to SNOP heuristic to all these heuristic output key figures. So in the next session, next presentation, we will talk about the entire end-to-end demand to supply plan. Okay, so that's the plan. For now, after this call, this video will be uploaded. This file I will share, and then based on this file, you perform the hands-on based on the MDT attribute values and input if your data hands-on that you have got here. Once it's done, then after that we'll have, or otherwise next Thursday I will set up one call. So by that time you should be able to complete this. And in that call, I will explain what to prepare for the presentation, and then we'll set up the presentation. Okay. Now we have less than 1 minute. Any time the call will end up. So Kshitish, after this call, we will see how to upload those files. Okay, your recording files. So we'll talk about that a little later.
Sure.
All right. So then let's close this call. I have anyways a meeting, and we'll talk later. Okay. Thank you for joining today. Bye.